This is demonstrating a manual white blood cell count preparation using the bioanalytic leukotic kit. This kit has replaced the Unipet, which was discontinued a few years ago. Again, I want to start out with a well-mixed, unclotted EDTA sample. Remove the top. The kit comes with 20 microliter pipettes, and you'll need to also have a pipette holder because the pipettes are quite small to be able to do it by hand. So you insert the pipette tip into the hook of the holder. Prepare your diluent by having your vial open. You want to fill your pipette end to end with blood. You want to wipe off the outside without sucking any of your sample into the Kleenex because you don't want extra blood on your pipette affecting your count. Then you're going to release the pipette from the holder by pushing in the end, and that tube actually stays in there. It does not come out. So after that, you mix it up. And you'll see that the pipette is in there with some of the well-mixed solution. It just stays like that. It takes a minimum of 30 seconds for the red cells to lyse, and the dilution is good for 4 hours for counting. So once the 30 seconds have elapsed, then you will flood your hemocytometer. There are the disposable ones that we find very convenient. They're clean. There is no cover slip to deal with. They don't break, and they take very little sample. And the sitting time in these hemocytometers is only 3 minutes versus 10 minutes on a traditional hemocytometer. So prior to flooding, again, you will mix your sample. They recommend a 10 microliter fill, but if you don't have a 10 microliter pipette, it's very common to just use a Paxel volume tube. Fill it about 3/4 full, trying to avoid any bubbles in the end because that makes it a little more difficult to flood. You'll notice that that little pipette that went in there initially stays in there. That's not what you use to flood your hemocytometer with. So you have a PCV tube. You're going to take it and touch it just to the very bottom of the half moon on both sides of the hemocytometer. So very gently release the pressure on the PCV tube to fill your chamber. So these sides are known as A and B, and you want to fill them both. Now that is a well-filled chamber. An example of an overfilled chamber, which then you would want to redo, which happens if you let a large drop expel. So that's why you only want to use a very small amount of pressure. Sorry guys, upside down. So if you see fluid going past the end and you get a dark blue line like that, you've over flooded it. And then you want to start over because your result will be inaccurate. Once you have filled your two sides, the hemocytometer should sit for 3 minutes, and that allows the cells to settle into a single plane prior to counting. If you're going to be delayed, it's a good idea to put them in a moistened petri dish or some such Tupperware container, something just to prevent evaporation of your dilution. For doing the manual white blood cell count on the disposable hemocytometer, this grid is what you will be looking for on your hemocytometer. You can actually see it grossly with the naked eye before you place it on the stage, and once you have it on there underneath the objective, so you shouldn't have any trouble finding your grid. For the manual white blood cell count, you're going to count, oh, if I had an arrow. Oh. The 4 large corner squares, so that's this one and this one, so all 16 of those smaller squares within the larger square. So the 4 corners is what you will be counting. So I'm going to move it onto the 10 power objective, which is what we actually do our counts on. And this is where you would commence your count in the top left-hand corner, and you would approach it systematically. So you'll go down and over and up and treat each one the same. And you're going to total the cells on each side, so not the total of each of the 4 corner squares. These small dots represent your white blood cells, and they're easier to appreciate under the microscope, I think, than they are on the screen here. So that's what you will be counting. You will find some cells that directly overlap a line. So for example, this one here is on the line, and this one here and this one here are on the lines. So what you want to do is just be consistent throughout your counting procedure and to count either the left and bottom or the right and top, and follow that throughout your count. So again, you'll just count all the white cells here and continue on counting all of these white blood cells. Continue on and continue on. And that is one side of the 2 sides of the hemocytometer. So you want to total that, write that down, keep track of that number. Then you will move your slide over to the other side and do the exact same procedure on this side. So again, you'll count your 4 corners. Here, and here, and here, and total that side. And we have provided the equation to then calculate your white blood cell count times 10 to the 9th per liter. In theory, the 2 sides should agree within 10%, but if the white count is high, that gets a little bit more difficult to adhere to. But if your 2 sides are out a ridiculous amount, then you'll have to reflood it. And that can happen from an uneven flooding to start with, or an unevenly mixed sample. When you do count them, you want to make sure that your substage condenser is low. If you have the condenser up too high, you will no longer see your cells because there's too much light flowing through, so you won't see them all. So make sure that your condenser is low enough that you can see your cells on there. And if you have counted it and then you go to look at a right game sustained slide, make sure you raise your condenser, because then you won't have enough light otherwise.